Hello, and welcome to section 8.3, day 2. Here, we're going to go through and continue the notes from yesterday about graphing functions in the form f of x equals ax squared plus bx plus c. As you can see at the top here, it's the same core concept we went through yesterday, but I just want to remind you. All right, remember the y-intercept is our c value. If a is greater than 0, it opens up. If it's less than 0, it opens down like a frown. All right, the x-coordinate of the vertex is negative b over 2a, and the axis of symmetry is x equals negative b over 2a as well. All right, this is important that we remember some of these things as we go through, and now we're not just going to find these points, we're going to graph these functions. Okay, so as we see here, we're going to now graph the functions in this form by following the steps. So we're going to find the axis of symmetry, right? And as you know, I like to call it the AOS, right? Which, as we should remember, is also the x coordinate of the vertex. Okay? Once you find the axis of symmetry, or the x coordinate of the vertex, find the y coordinate of the vertex, and we're going to pick at least 2 points to the right or left of the axis of symmetry and find the y values. All right, if we can use the y-intercept, we're going to. All right, the next couple steps is going to go through. We're going to draw on the axis of symmetry, either with a dotted line or a highlighter. We're going to plot our points to the right or left. We're going to reflect those points to the other side of the axis of symmetry, and then we're going to connect the points. Okay? Seems like a lot of steps, but trust me, these last couple here will save us a lot of work. All right, so let's take a look at our first one here. So when we look at our first example here, it's asking us to graph it, describe the domain range, and whether the vertex is a maximum or minimum value. Okay? Just like in the last video, when I want to go through and find these things, I'm going to say, well, what's my A value, my B value, and my C value? Okay, so when I do this, I'm going to go through, and now remember, our axis of symmetry is x equals negative b over 2a. So 2 times 2 is 4, and 4 over 4 is 1. So our axis of symmetry in this case is x equals negative 1. All right, so we know that that's going to be the negative 1 in our vertex. Well, how do we get the y-coordinate of our vertex? We just plug it back in. So we would say f of negative 1, sorry, I already made a mistake here. F of negative 1 equals 2 times negative 1 squared plus 4 times negative 1 plus 1. All right, remember to do our orders of operations. So negative 1 squared is 1. 2 times 1 is 2. 4 times negative 1 is negative 4 plus 1. Negative 2 plus 1, which is negative 1. So that's the y-coordinate of our vertex. Okay, so now as we go through it, I just want to look at it and see, well, to remind myself, does this open up or down? And then I'll answer the rest of the questions. Well, we know that our A is positive, so this is going to tell us that this opens up. Okay, so now what we need to do is pick some points to the left or right of the vertex. So I'm going to draw a table in here. We have all this extra space, which is great. And I'm going to put my vertex right in the middle, which is negative 1, negative 1. All right, now what I'm going to do in this case is I'm going to choose points to the right. So I'm going to pick 0 and 1. All right, so now the nice part is if we have 0 here, remember that that's the y-intercept, which is our C. Right, 0 comma C is our y-intercept, so that's 0, 1. And the last value I'm going to plug in here is 1. So I'm going to say 2 times 1 squared plus 4 times 1 plus 1. 1 squared is 1. Now I'm going to do the multiplication. 2 plus 4 plus 1, 6 plus 1, f of 1 equals 7. All right, so now that I have these points, all right, what I'm going to do is I'm now going to plot my vertex, which is negative 1, negative 1. I'm going to draw in my axis of symmetry with a highlighter or a dotted line. Remember, axis of symmetry is a vertical line that goes through our graph. All right. And now I'm going to plot my other points. So 0, 1, I'm going to plot, and 1. Oh, 0, 1's right here. Sorry. That's my mistake. I'm having a rough go at it right now. And 1, 7 all the way up here. Now, the nice thing about the axis of symmetry, if we realize it here, right, what's going to happen is we're going to reflect this point. So if we look at the y-intercept here, that's 1 to the right. So if we reflect that 1 to the left, that's now going to give us the point negative 2, 1. And now if I go up to the next point, 1, 7, that's 2 to the right. So I'm going to move it 2 to the left. So that would be negative 3, 7. And now we have enough points to graph our curve here. So we connect it with a smooth, continuous line. And there's our graph. Okay. Now, we still have a couple more questions we're going to fill in here, and I like to go through in a certain way. All right, but we notice the domain in this case is always the same for any quadratic, all real numbers. Now, does our graph here have a maximum or minimum? Remember, if it opens up, it will always have a minimum. And now when we talk about the minimum, we're only going to talk about the y value. So the smallest y value we have here is y equals negative 1, which is going to tie into our range, which is going to tell us that y, because it's a minimum, is greater than or equal to negative 1. Okay? So that is our graph for the first one. All right, moving on to example 2. With example 2, our A is 1, our B is negative 8, and our C is 7. Okay, so when we go through and do our axis of symmetry, x equals negative b over 2a. That's negative 8 over 2. So that's going to be negative of negative 4, which is going to tell us our axis of symmetry is really 4. And remember that that's also the the x coordinate of our vertex. Now when we want to find the y coordinate of our vertex, we just plug it back in wherever we see x. Order of operations tell us to do the squared first. That's 16 minus 8 times 4 plus 7. 8 times 4 is negative 32. All right, 16 minus 32 is negative 16 plus 7. So f of 4 equals negative 9. So that's the y coordinate of our vertex. Now we realize something here as well. If this a value is positive, it is going to open up, okay? And if it's easier for you to go through and plot the vertex now, that's totally fine. We can do that now. 4, negative 9. All right, so now when we go through, we're now going to go through and pick some other points to the right or left. All right, we're going to put our vertex right in the middle. All right, in this case, I'm going to pick my x is 5 and my next x is 6. All right, if we notice something, here's a little hint to you. However many we go to the right, we're also going to go that many to the left, so we know our x's, and we just need to find our y's. Okay, so if I plug in 5, we'll do 5 squared minus 8 times 5 plus 7. 5 squared is 25 minus 40 plus 7. Negative 15 plus 7. So f of 5 is negative 8. And the last one we're going to plug in is 6. So 6 squared minus 8 times 6 plus 7. 36 minus 48 plus 7. Right, that's 6 squared. 8 times 6 is 48. 36 minus 48 is negative 12 plus 7. And negative 12 plus 7 is negative 5. All right, so we can plot those points. All right, negative 5, negative 8, and 6, negative 5. All right. Now remember, we want to graph our axis of symmetry here to make it easier for ourselves. So if we go where x equals 4, we're going to go through and draw our axis of symmetry. All right, and now we realize that this point here is 1 to the right, so we move it 1 to the left. So 3 is actually also at negative 8. If we move 6 to the left 2, to the right 2, so we're going to move it to the left 2, so that will be 2, negative 5. Okay. Now, there's one more point that we know here, okay? It's actually 7, or 0, 7, way up here, because that is really the y-intercept, right? And even if we think here, if that's the y-intercept, this point is 1, 2, 3, 4 to the left, so we can actually move it over 1, 2, 3, 4 to the right to get an even better picture of our graph. All right, so notice that extra point here really gives us a better view of what's actually happening to our graph. All right, so let's answer the domain and range questions. Our domain, my favorite question, all real numbers. Once again, this is the lowest point, so it's a minimum at the y-coordinate of my vertex, which is negative 9. And that's going to tell me that because it's a minimum, that y is going to be greater than or equal to negative 9. Okay? All right, so that's our second one. We're going to do one more together as a class, and then you guys are going to do one as a U-Try for homework. Okay? So number 3 here. All right, our A is negative 1/2. Our B is 4. Our C is negative 2. Our axis of symmetry is negative 4 over 2A, which is negative 1/2. 2 times negative 1/2 is negative 1. All right. 4 divided by negative 1 is negative 4. And a negative of negative 4 is positive 4. All right. So once we have the x-coordinate in the vertex, we need the y-coordinate. So we're going to say, well, what's g of 4? Orders of operation tells us to do the squared first. Negative 1/2 times 16, we'll think, what's half of 16? It's 8. We make it negative. 4 times 4 is 16. Negative 8 plus 16 is 8. 8 minus 2 is 6. Okay, so we have some information we can kind of go through and look at now. We know our vertex is at 4, 6. Right? And we know here that our parabola is going to open down. Remember, it's going to open down because our A is negative here. Okay, so now we're going to go through and get some y values. We're going to put our vertex right in the middle. Now in this case, I'm going to pick points to the left just to be different and show you that it can be the same thing no matter how we do it. So 2 points to the left are 3 and 2. If I pick 2 points to the right, that will be 5 and 6. So now I already have all of my x values chosen here. All right, so if I now say, well, what's g of 3? I plugged it in wherever I see x. So negative 1/2, 3 squared, plus 4 times 3, minus 2. Orders of operation tell us to do the squared first. 3 squared is 9. Half of 9 is 4.5. We're going to make that a negative. 4 times 3 is 12. All right, and if you need a calculator here, that's totally fine. All right, negative 4.5 plus 12, right, is 7.5. Minus 2, this will be 5.5, and that's at 3. All right, and the last point that we're going to plug in that we need here is g of 2. Negative 1/2, 2 squared, plus 4 times 2, minus 2. Our orders of operation tell us to do negative 1/2, or sorry, the 2 squared first, so 2 squared, which is 4. Now we're going to do the multiplication. Half of 4 is 2, make it a negative. 4 times 2 is 8. All right, then our minus 2 at the end. Negative 2 plus 8 is 6. 6 minus 2 is 4. Okay, so we're ready to graph these things. All right, so either highlight or do your dotted line for your axis of symmetry. So we have that there. And now we're going to plot our points. We have 3, 5.5. Do your best to estimate it. And now we notice that this is 1 to the left, so we're going to make this 1 to the right, which is 5.5. Now the next point we have is 2, 4. That's 2 to the left, so we move it 2 to the right. So 6 is also at 4. All right, and now just remember, there's one other point that will help us here. 0, negative 2, which once again is the y-intercept, right? And this point is 1, 2, 3, 4 to the left, so we move 1, 2, 3, 4. All right. And now we just kind of connect our graph. All right, and now we answer the rest of the questions. The domain, love this question, all real numbers. Now notice here, this opens down, so this has a max value at y equals 6. That's the y-coordinate of our vertex. So our range now is going to be y is less than or equal to 6. Okay. All right, so that was the video for today. Do me a favor, or do us a favor. Number 4 is going to be a U-try. Please go through and follow the same steps we're doing for number 4. Once you're done, take a picture of your work, add it to your class notebook, and then submit it through Teams. Have a great day. If you have any questions, let us know. Bye.